in order to write this book, which I hope you can buy a copy. It's online, okay, which is called, iMind, Artificial and Real Intelligence, and it's published by Routledge. Routledge is a very famous and the oldest publisher in the world. His head office in London, England, and many offices in the world. And I was happy actually they took the book, because the book is risky, because it's new, and try to bridge the knowledge gap between AI and RI. Very difficult. So what I decided to do is to write this book. I sent the Routledge the outline, and they accepted. Okay, let's talk about expert system, because this will lead to AI. Expert system is a software which is different from the regular algorithmic driven software. It is actually, it helps itself by learning from experts. So let's say we want an expert to do a software to convert, for example, an X-ray of somebody who suspected to have cancer into he has cancer, and accuracy is 70, 80, 90%. So this means what we do, we get a program, okay, a software guy sitting here, and an expert radiologist sitting here. So they talk to each other, and they have many data points, 1,000, 100,000, 1,000,000, to see how the program can code this expertise into this. It's a learning process, exactly what this is in here. So what happened is, we lost the interest of expertise because they were afraid that they convert their expertise to a program and they become out of job. Stop. The expert system dead on arrival in about 10 years, in mid-80. And I converted from artificial neural networks to other research areas, which I will talk to you about later. About 10 years, maybe 5, 10 years later, they got a sexy name for the expert system, which is called artificial intelligence. There is no intelligence in this. No intelligence. It's the same expert system that we use the expertise to perform and improve and enhance performance. But it catch on, got money from the governments, and people start paying attention. It's exactly the same. You teach a program with the help of expertise in order to perform a certain task. So now let's talk about the example of the radiologist. Can a program, AI program, who predict that this X-ray of that person has cancer, we say 95% accuracy? Yes. Can that program replace the expert? No. But he can be helpful as a trainee, in the level of the trainee of a radiologist. Or in a rarer area in Sarawak, there is no top expert in this. So this is the first filter that the hospital in Sarawak who can send this to the AI, it's a back end of the X-ray, and see what is this. It's a binary decision. Yes, he has cancer. No, he has no cancer, or maybe. So in case of maybe, you have to bring it back to an expert, a real human expert, to decide. Maybe you need extra test, maybe. And the AI program will use exactly the same algorithm in the mind of the expert radiologist. The expert radiologist will ask about gender, about age. He look at the X-ray. What's the distribution of the spots? how long this person is coming to this, what's the environment for this person, the upbringing, the genetics, and so on. And then based on all of that information, he decide, yes, I need further test, or yes, this person has cancer, okay? So all these are taken into account in a good AI. The more data points the AI can have, the more accuracy it can reach. Now let's talk about the back end of this. AI is based on the hardware which run it. Could be a general purpose CPU, or could be a special accelerator. And I want to talk in the meeting about special AI accelerator. So this means that if you have a certain application and you need a really high accuracy, it is worth it to convert some of this into a special purpose hardware in order to speed the algorithm for the AI. Okay, it's expensive, but if you have too many of these, you can actually afford it, and it will be worth doing it. Now let's talk about RI. This is a fun, okay? RI, which is based in the brain really, and I use the analogy of the computer software and hardware. Software and hardware. And actually this is in Quranic Arabic, is that the hardware, which is the mokh, is not mentioned in the Quran. The hardware itself, which is the mokh, which is actually, you can see it in many graphics like that. It's actually made of fat. It doesn't mean that the more fat you eat, you get smart. No, it doesn't work that way. But it's 100% fat. See God's design? Fat, which has bad name. But the brain hardware needs a software to run it. And this is in Arabic called aql. And this is the one mentioned in the Quran. So the hardware is useless, more or less useless, without the software. And the software has many layers, many layers. The first one is pre-programmed. This cell phone here, Dr. Sharafuddin mentioned my student Mike Lazardis of BlackBerry. The first mobile device in the world was BlackBerry in Waterloo. Now we can have many companies producing this. But this hardware is useless if you buy it without a pre-program called operating system. Useless. So at the manufacturer level, after they tested the hardware, they put